Okay, yesterday we started with the vertical curves. So vertical curves have the shape of what? A parabola. Okay, and then we have two types of vertical curves, which are sag and crest. And how do I know which one is sag, which one is crest? Yeah, it's one. G1 is more than G2. It's a crest curve. Okay. Then we looked at the terms and the equations for this curve. Okay, and the equation of parabola was to be used, and in that equation we had some constants a, b, and c. So we calculated the values of a, b, and c, and then we also have an equation for calculating the position of the highest point of the curve and the lowest point of the curve. Okay, and as I mentioned earlier, in most of the cases it will not be the midpoint. Okay, and in none of the cases it will be the point of intersection. Okay, point of intersection cannot be the highest or the lowest points because it's not on the curve. Okay, a vertical curve 600 feet length is given, G1 and G2 is given, elevation of VPC is given. So VPC means what? Beginning of the curve. Find out the elevation of VPI, highest point of the curve, and VPT. Okay. So let us start. First of all, which type of curve is it? Crest vertical curve. Okay. G1 4%. G2 minus 2%. Okay. What is 600? The length. Okay, and I have VPC elevation 1250 feet. Okay. 600. Okay. Let us start with the easiest of things, which is the elevation of VPI. Okay. Let me show you the picture. In all the curves, where is VPI? In the middle. Okay. Point of intersection in terms of distance is in the middle. Okay. How much is the distance between VPC and VPI? 300. It's in the middle. Okay. It's in the middle. So you know the distance, and they gave me the elevation of VPC, and I also have what? The gradient. So you know the distance, you know the initial elevation, and you know the gradient. Okay, so you can calculate the elevation of VPI. Okay, elevation of VPC, the gradient into the distance. How much? One, two. For VPT, what should I do? Say again.
G2 squared by the distance plus VPI.
Yeah. Now you have VPI, and then from VPI you are going down. Okay. Forgot that. think so. Okay, so for VPT, we can use VPI as well, which is now how much? 12.62. Okay, how much is this? Okay, now for the highest or the lowest point, they said they want the elevation of the highest point. So first of all, I should know where is the highest point. Okay, as I said, it's not the middle, and it's not VPI. Okay, so for the highest point, we have this equation. You need to calculate the value of x. We know G1, and we know L 600, and we know G2 as well. Give me the value of x. Huh? 400. Okay, and you put the value of G2 as negative, right? Okay, now how do I find out the elevation of a point which is on the curve at a distance of 400 feet? Why? Equation of? We have the equation for the parabolic curve, right? This one, yx equals to this thing. So yx is the elevation of any point which is at a distance of x. In this case, the x is 400. Okay, so you put x as 400 feet. You know L, okay, which is 600, and G1 and G2, 4 and minus 2. Okay, so give me the value of elevation. It gives you the value of elevation directly. How much is it? Y means elevation. You want elevation, right? Calculate.
Doctor, in calculating the elevations of PI and PP, do we consider the sign for the gradient?
We did, right? Plus 4. When you were calculating VPT, we did minus 2.
The minus was because it's lower or because of the sign?
Because of sign. And calculating elevation, the gradient is downward. You are supposed to subtract it, right? You want less value.
Did I get 1, 2, 4, 3?
Sorry?
1, 2, 4, 3.
I don't know. Maybe. You calculated it. If you don't know, how can I know? Call it Y for the highest point. And I also call it the X for the highest point. Not any X. This is the X for the highest point. How much did you say? 1, 2?
For me, 1, 2, 4, 3.3.
No.
One,
Said what? Highest point. Highest. So it should be highest. You already have elevation of VPC and VPT. So it should be more than this, right? How much? 6. Yeah. It can.
1271.9.
We should do voting now. We should do voting. Yeah, anyone else? Can someone confirm it is not? 1, 2, 5, 8. 1, 2, 5, 8. Okay. So G2 will put as -2, G1 4, okay, and 200, and L is 600, and X is 400. Okay.
The whole thing is under the denominator.
Sorry.
The whole thing is under.
No, X is multiplied. X is multiplied.
So only the first part.
This yeah, this is the denominator. Then this whole ratio multiplied by x square. Okay, x is multiplied. Okay, and same thing here, G1 upon 100, and then x is multiplied. Okay, and plus y0. What is y0? VPC. Okay, the one which is given. Clear? Okay. Now, if I ask you to give me the elevation of the point which is in the middle of the curve, what would you do? Give me elevation of a point which is in the middle of the curve. What would you do?
300.
You would put x as 300 in the same equation. Okay, but we said VPI is in the middle. It's not on the curve. Clear? So VPI is different. A point on the curve is different. Okay. Another thing you can do to check your calculations, you calculated VPT, right? We can calculate VPT using the equation as well. How? This equation I need. You can calculate VPT using this equation. How? Yeah, you put x as 600. X equals to length. You already calculated VPT. This equation can give you a check. Clear? Okay. Any questions? So the same criteria of side distance must be satisfied on the vertical curves as well. And we again have the same problem that the curvature may block your line of sight, which you can see here. Okay. So if I'm a driver here, can I see the road which is on the other side of the curve? I cannot, right? Okay. So this is, if it had been a straight road, I would have seen what is on the other side. So again, the problem is the curvature. Okay. Now here, the curvature, since the curvature itself is blocking the line of sight, so I can only control the curve itself. For the horizontal curve, what did we do? We said the object which is on the side of the road is blocking my line of sight, right? So I will remove the object. I will have some distance for it. But here, the curve itself is blocking my line of sight. Okay. So it's not something else. You have to change the design of the curve itself. Okay, there is no other object here. So they have given us equations which satisfy the side distance criteria and control the length of the curve. So you can use these equations, 4 equations, one of the 4 equations obviously, to calculate the length of the curve such that the side distance is satisfied. Whatever side distance you require, is available on the curve if you are satisfying this equation. Okay, so we have two equations for the crest curve, second column, two equations for the sag curve in the last column. Okay, so the first equation for the crest curve is when side distance is more than the length of the curve. Okay, and same thing for the sag curve as well. You will use the first equation sag curve if side distance is more than the length of the curve. Second equation, when side distance is less, length is more for both cases. Clear? So you should know the type of curve, and then you should know whether side distance is higher or lower than the length of the curve. Clear? So any length which satisfies or which comes from this equation and satisfy the criteria, you have enough side distance which you need. Okay, and what I said earlier, the ds will be what? Most of the time is stopping side distance, most of the times, but it can be decision as well, it can be passing as well, any type of side distance which you want to give at this location. Okay, yeah, so in these equations, if you go back to the highway engineering book or maybe some other books, you will see there were some constants in the equation, there were some factors in the equation which they have assumed the value for. Okay, there were two factors in all of these equations, all of them. One was the height of the driver's eye, the height of the driver's line of sight, and the other one was the height of the object which the driver is looking at. Okay, so for example, if you see this, I cannot see if a car is on the other side, right? But I can see the trees and I can see the buildings because they are very high. Okay, so I'm taking the most common and the worst case scenario that the object is very low. Okay, the object which I'm trying to see on the other side is very low. And what is that object? Another car. Okay, the most common case. Okay, the most common case, the most frequent case which you have to look for. So the height of the object is taken as the tail light of the car. Okay, the height of the tail light of the car, the rear light, the brake light. Okay, the rear bumper. Okay, so that height is taken as 2 feet. Okay, and the height of the driver's eye above the ground level, the driver's line of sight above the ground level is taken as 3.5 feet. Both of them are for cars. So object, we consider the tail light of the car, and the driver is also a car driver, not a bus driver. Why?
Because the bus is higher.
The bus is higher, so obviously driver has more sight. Okay, the driver is at higher elevation. So you take this. So for the vertical curves, I showed you the curve is blocking the line of sight, right? What about the for the crest curve? For the crest curve, I showed you. The last picture was for the crest curve. What about the sag curve? Now for sag curve, normally you are coming like this from top to bottom, right? Okay. So in most of the cases, when we have enough light, side distance is not a problem. For a sag curve, usually side distance is not a problem, unless your line of sight is strictly following the headlights of the car. So there is no other light. It's a dark night. You're in the middle of the road. Okay, and only light you have is the headlight of the car. That's it. So your line of sight is basically what the headlight is showing you. Okay, because of the design of the crest, the design of the sag curve, there is no curvature in front of you, right? Okay, and you are coming like this. So the only problem you can have is there is darkness around you. Okay, and for some weird reason you are still on the road. Okay, so you have the headlights to see, and that's it. Clear? Okay. So these are the things which they have assumed in giving you those equations. Okay. What is the minimum length of vertical curve that must be provided to connect a 5% gradient with 2% on a highway with design speed of 60 miles per hour? Driver reaction time normal. You already seen it. Normal braking, 2.5 seconds, and simple stopping reactions. Okay. So they want the length of the curve, right? So for finding out the length of the curve, I have those 4 equations. The first thing I should know is what type of curve I have. What is it? Huh? Crest. Yeah, G1 is more than G2 and it's crest. Okay. And you can see both are positive, but still it's a crest because G1 is high. Huh? Something I mentioned yesterday. You can have 2 positive gradients and you can have 2 negative gradients as well. Okay, so it's a crest curve. So first thing is I will look for an equation from the second column. Okay, so I can either take the first one, assuming that ds is more than L, side distance more than L. I can assume the second one, assuming that ds is less than L. Okay, so for that I must know ds, right? So let us calculate ds because it is required in the equation as well. Give me a second. Okay, this is the equation. Sorry, I made a mistake here. There should be S as well. Okay, so we know S, we know T is given. Okay, and we need F and G, right? Okay. Now for F, there were some standards, right? They mentioned it. We have the speed. Yeah. Oh no.
0.34. Yeah.
Okay, I mentioned in the last chapter as well. This is a different F than the F you were using for radius. Okay, this is what they call as skid resistance. That was side friction. Okay, so this F does not depend upon speed. It depends upon the deceleration and gravity, A upon G. This is capital F, which is A upon G, deceleration upon gravity. The one which you use for calculating radius, that was small f, skid resistance. For that we have a table. Okay, but this is A upon G. Okay, so Ashto gave us a standard value of A, deceleration, which was 11.2, and since G is a constant, so we already calculated the value of F. That was 0.348. Okay. So since no other data is given, I will assume that there is standard deceleration. I will take F as 0.348. So F is solved now. No problem with that. Okay. G. I have now 2 options for G. I can take G1 or G2. Which one should I take and why? The higher. Why? What is the worst case? G1 or G2?
First one. The first one.
Why?
Because it gives greater distance.
Yeah, the worst case which gives us more ds. Okay, the worst case is whichever one gives us more ds. Okay, so which one will give you more ds? You look at the equation, it's in the denominator, right? So I should put what?
2.
2, right? Denominator is smaller, the value will be bigger, right? Or no? Okay, so we will take the lower one, always the lower one. Clear? Okay, out of the 2 options we have, we will take the lowest one, because you put lowest one in the denominator, ds is higher. Okay, so how much is it? So you will put 0.02, okay? There was 0.01 multiplied, I did not write it. How much? Okay. So now I know DS. Okay, so then again, all the equations are asking for A as well. Okay, so let us calculate the value of A as well. It is required for any equation which you choose. Okay, so what was A? What? G2 minus G1. But that's fine. Absolutely. Yeah. So A absolute 5 minus 2. For those who are trying to do it by calculator, shame on you. There are people who do this. 2 plus 2, they will take out the calculator. 5, 4, 6.
I got this 517. 517.
5.
17.
Who got 5, 4, 6? So many people against you. So what did you say? 5, 4, 6.6. Okay, by the way, if any of you have a problem in calculation, okay, you can show it to me later on, no problem. Okay, you can show it to your friend, or you can, after the class, you can show it to me. Okay, I can tell you where was the mistake. Okay, so we needed DS and we needed A in all the equations. So these are the two things which I have already calculated. Now I need to select one equation. Which one should I select? I have to select from the two which are given for the crash curves, right? The first one or the second one? Randomly. Okay, we assume randomly. Okay, so give me a value from any of the equations. You can tell me which equation you chose. Give me a value from any of them. Because we do not know L, so we are not sure.
But it's going to be
415. Our DS was how much? 500 something, right? So now this equation cannot be correct because the condition is not fulfilled. You can choose any equation randomly, but after calculating the values, then DS must be less than L. If you chose this equation, then whatever L you got, it must be more than DS. It's not? Give me the value from the other equation. 373 point? Any questions? Yeah? Okay, then if somebody asks you for elevations, again, we do the same process as we have done earlier in the last example, in which the length was given. So now you are at this stage, that stage, where you can start using the other equations, start calculating elevations and so on. Clear? Now, if you use the second equation, so my DS was 546 or whatever. Okay, you use the second equation, it must be less than DS, right? And then you get a value 600 from the second equation.
Okay, use it. More than second equation, more than DS. Is more than DS.
Second equation is
more than DS.
L is less than DS.
Second equation.
I mean the second which we used.
Okay.
So you use this equation, L came out to be 415, which is against this condition. Okay, so we cannot use this equation. Now you use this one, and L comes out to be 600, which again does not fulfill this condition. This is not possible. Okay, so when this happens, you give me the paper and go out and expect an F. Okay, this cannot happen. You will fulfill one of the conditions. Clear? Okay, at least one of the conditions would be fulfilled. Okay. Now the third part of highway geometry, the cross section. For cross section, you cut the cross section, right? Okay. So the things which you can see in the cross section of the road include the lanes, the shoulders, the side slopes, the curves, the median, any barriers which are on the median, if there is any guardrail on the side, any drainage channels. Okay, so all are these things which are part of the cross section of the road, or their design is part of the cross section of the road. The design of these things is part of the design of the cross section of the road. Okay, you can see a typical cross section over here. Okay, now you know lanes, you know shoulders, you know medians. Okay, we know barriers and rails as well, guardrails. Okay, these barriers you have on the side. We know drainage channels as well, drainage channels to collect water and move it from the road. Only thing is the side slope, okay, which I think you cannot see here. Yeah. Okay. So what is the purpose of the side slope? Side slope. Yeah, it's for stability of the road. Okay. So it's basically the slope which is providing the stability to the pavement, the road itself. If you don't have any slope here, under the load, the pavement will slide. Okay, the material will slide. So it's already mentioned. So what are the design standards for each one of them? Now later on, we will see how each one of them can affect capacity and traffic flow. Okay, but for now, we just talk about design standards, the ranges and the preferred values and so on. Okay, but so you will not see any equations here. But whatever value you take from here, that will affect something else. Okay, so it's like you have to back calculate. So you took some width of travel lane, and then you calculated the capacity, which is coming out to be less than what you want. So to increase the capacity, I'll change the width of the travel lane. Okay, and so on and so forth. So there are no equations here, but the values which you are picking from here, they are used in some other equations. So you may need to back calculate them. Okay, so we'll use it later on. So what are travel lanes? Travel lanes are the paved areas. One of you, I don't know which one, but one of you had a question. They thought that the pavement means the sidewalk. Okay, so these are, one is the UK terminology, the other one is the US terminology. Okay, in US, pavement means the road itself. Okay, and the pedestrian area on the side is called sidewalk. Okay, in UK, that area for the pedestrians is called as pavement, and the road is, I don't know, road, I think. Okay, so but for now, just stick to the terminology of the book so that you don't have any confusion. Okay, so the pavement is the one which is a paved area where you are providing a smooth surface with the structure and the layers for the operation of the vehicles. Okay, the standard width is taken as 12 feet or 3.6 meters. Okay, minimum width 9 feet. Okay, yeah, and you may go for more width on the curves, and we already discussed the reason for that a couple of times earlier. What is the reason? Why do we provide more width on the curves? For the trucks mainly. Okay, so the trucks, because the trucks cannot follow the circular path, so we provide them more width so they can go zigzag and still be in the lane. Okay, so on the curves you may see pavement width which is even more than the standard one. Okay, so the normal range is 9 to 12 feet, but on the curves you will see even more than that. But even in Bahrain you will see some lanes which are more than 3.6 meters. Okay, on even on normal roads. Okay, because we are kings of the road, right? We are expecting maybe some Formula One driver will come out of the circuit, start driving on our roads. Right? They drive here. These F1 drivers. They drive here. They just come from the plane and go to the circuit, right? They only drive there. Right? Otherwise, they will ask for money. Anyways. Yeah. Now, the width affects two things on the road: the capacity and the operation of the road. The width of the lane affects the capacity of the road and the operation of traffic on the road. Okay, so if you increase the width, the capacity also increases and the operation becomes smoother. Okay, a parameter for traffic operation is speed, right? So speed also increases. Okay, and vice versa. Okay, so obviously on all roads you don't need the same capacity, and you don't need the same speed, and you don't have the same space. Okay, so there's a trade-off now. I want to maintain high speed, then I need more space as well. Okay. Yeah, so we only go for lower width when we are doing it for low volume roads, because obviously then you need less capacity, and maybe low speed roads in the residential areas or the rural areas. Okay, because they are low speed. Okay, so wherever you need low speed or low capacity, you can provide low widths as well. These lanes have a cross slope. Okay, we already discussed them, right? The cross slope. Okay, so they have a normal cross slope, and then they have what? They have a normal cross slope, and what else? Super elevation. On the curves, they have super elevation, and outside the curve, they have their normal cross slope. I showed you it's like this, right? Okay, so what is the main purpose of these slopes? Cross slope, drainage. Okay, and yeah, so this is what they are saying. So usually super elevation is higher than the normal slope. Okay, so when you provide super elevation, you don't have to worry about drainage. Your drainage will happen even faster. Okay, but you have to worry about what should be the normal cross slope on the outside the curve. Okay, and for that they have given us some ranges. Okay, for high type pavements, the cross slope can be 1.5 to 2%. Now, high type means they have high speed, and they are having high load of traffic. So this is what we call as high type pavement. So for high type pavement, the cross slope goes from 1.5 to 2%, and for low type pavement, then goes from 2 to 6%. Okay, why it is lower for high type pavement? The cross slope. Lower cross slope means slower drainage, right? Water will go slowly. Okay, high. So on high type pavement, we are reducing the drainage basically. Why? The car doesn't slip. Okay, good, good. What other reason? What did I say about high type pavement? Heavy vehicles, they can be heavy vehicles as well. Good, good. Anything else? What? Either you stop, or I will keep on asking what.
He said we still up.
Huh?
We you still up.
No, he's asking you. You tell him. He's not telling me. Okay. What did I say about high type pavement? High type pavements are what? What do they have? They have high speed. Okay. So in order to maintain high speed and then make sure that the vehicles can go smoothly at high speed, you have to make sure that the pavement is as smooth as possible. Obviously, cannot make it zero because then there's no drainage. Okay. So that's why the slope is lower, so that it can, even the heavy vehicles and heavy traffic can go without any slippage or overturning, and the other drivers can also maintain high speed. Okay. Obviously, the vice versa for low type pavements as well. And the difference between the high type pavement and the low type pavement is their material. High type pavement have a stronger material. Okay, like they apply some special coating on it and extra layers. So even if the drainage is slower, it will have less damage. On low type pavements, the material is lower quality. Number of layers are also less. There's no extra coating or something. Okay, so we want the drainage to be fast, so the water does not seep into the pavement. Okay. You can have drainage on both sides like this. Okay, so drainage is happening on this side of the road as well as on this side of the road. This is the most commonly done scenario because it is the most efficient one. Having drainage on both sides is the most efficient one, but that also means I should have what on both sides? Huh? Channels. Drainage channels. Okay, the water has to be carried somewhere, right? Okay, so on both sides you should have drainage channels to collect the water and then transfer it. Otherwise, if the water keeps on accumulating, at some point of time it will come to the pavement as well. Okay, so you can do drainage on both sides or on one side depending upon wherever you are giving the collection structure. Okay, where the water will be collected and taken off. Okay. Yeah, in some cases where the rainfall is very low, instead of having drainage channels, we just keep the area empty, like the not paved, unpaved, loose material, natural soil. Okay, and we believe that the water will be absorbed into that soil. Okay, but that will only work if the rainfall is low and we have enough capacity of the soil to absorb the water. Otherwise, the same thing will happen. The water which is not absorbed, it will be on the top and it will keep on coming towards the pavement and so on and so forth. Okay. So normally the cross slopes are increased by an amount of 0.5%. Okay. So the first lane has a least cross slope. The second one has 0.5% higher. The one after that will have more 0.5% and so on. Okay, and this is why usually the outside lanes are for slow vehicles, right? If you have to specify a lane for trucks and buses, that will be the outside lane. Okay, because it has a steeper slope. Okay. Can we have this cross section on the curves? Like this, can we have both side drainage on the curve? No. Because slip elevation is only, you have to raise the outside edge. There's nothing like this. Okay. Shoulder. So shoulder is the part of the road which is contiguous with the traveled way, with the travel lane. Contiguous means parallel. Okay, going together. Okay, and we use shoulder for what? Emergency? Stopping in emergency, yeah. Some of us use it for going in emergency, which is wrong. Okay, so now they are becoming very strict. I see like police cars which are standing on the shoulder, and if you now, for the last couple of days, so you see the police car and you are on the shoulder, and then you do what? You go outside, right? So they are marking a number, then they are asking you to come. Okay, so they can find you. Good. So shoulder can be the same surface as the the pavement itself, or you can make it of loose material and so some other material as well, because it's not for the normal operation of the traffic. Okay, so the material of the shoulder can be different from the material of the lane. Okay, the shoulder width goes from 2 feet to 12 feet, and again it will affect the speed and the capacity. When you increase shoulder width, the capacity and speed, this also increases. Okay, although you would say why? The vehicles are not on the shoulder. If I increase or decrease the shoulder width, what does it have to do with the drivers? It's a psychological effect. Okay, it's a psychological effect because shoulder provides a clear area. So when you see more clear area beside you, speed is usually higher. Okay, and higher speed results in more capacity as well. Okay, but whatever you are using, the shoulders should be stabilized. Okay, like they should have a smooth surface. Whatever material you are using, it can be natural soil as well, but you have to level it. You have to make it smooth and according to a particular slope. Okay, or it can be fully paved as well. Wherever you are using two different materials in the shoulder and the lane, you have to make sure that they are joined together. There is no gap between them. If you are using the same material, then obviously you will fill it completely. But even if you are using different materials, you have to make sure that there is no gap, because then the drainage will be in the gap. Okay, so it will directly go under the surface, which is very dangerous. On rural highways, and now we are talking about rural highways or freeways, so the speed is very high. So there are rural freeways and there are urban freeways. Okay, which one has a higher speed? The rural. Okay, because they have less population, less distractions, and so on and so forth. The area is usually clear. You have more space. So rural freeways are very high speed. Okay, so the shoulders become necessary for these high speed roads. They just gave the example of rural freeways, but any road which has very high speed, the shoulder is necessary. Why? For emergency and safety, right? The safety. Okay, even if you want to, there's some problem with your car, now you want to go slower, you cannot be on the road. Because people are coming at 100, 120, 140 kilometers per hour. It's dangerous for even a slow moving vehicle to be on the road. Okay, so it's important that you provide this on the main freeways. Normally we use a shoulder width of 10 feet, but you can provide a width as narrow as 2 feet where you have, for local roads and so on. Okay, so we said the shoulder is for stopping, right? So you stop on the shoulder. In 2 feet you cannot fix a car. A car has a width of, I think, 9 or something. Okay, so what will happen when you give a shoulder of 2 feet? What will happen?
You can't stop anyone.
Sorry?
In local roads, you can't stop anyone.
Yeah. Okay, so if the road is low speed and low volume, so even a car which is half on the lane, half on the shoulder is not a big issue. So you try to save your space by providing a smaller shoulder, because the risk is lower. Okay, even if a car is stopped on the shoulder in emergency and it is somewhat on the lane as well, it's not so dangerous. Okay. Some functions for the shoulder. The first one we already said. Okay, the first one is done. It can provide a buffer for accident recovery. So you are hit by a car, or your car lost control, the tire burst, something happened. Okay, so now with the impact or because of anything, you are on the shoulder. So the shoulder is supposed to be clear. So shoulder is the portion on which you can try to stop your car or try to get the control back of your car. Okay, the car got out of control, the safest place to be is on the shoulder. Okay, so we call it a buffer. Buffer means now it is acting as a medium between the traffic and the roadside. It's clear, right? It does not have any obstructions and does not have any traffic as well. So buffer means it's a medium. Okay, like a separation. The third point I already mentioned. Psychologically, when you see more space on the side, you feel more comfortable. Okay. On horizontal curves, shoulder is part of M, horizontal sideline offset, because it's a clear space on the side of the road, right? So when you increase shoulder width, you are also increasing M value as well. Any object will come after shoulder, right? So it provides you, it helps you in providing side distance as well. Okay, capacity already mentioned. Yeah, you want to do some maintenance on the road, you will block one lane, you will close one lane, but the traffic is still coming. So these people can use the shoulder. Okay, the many highways on which they have done it. In areas where there is snow on the road, so usually you cannot have trucks which continuously come and remove snow while you move it away from the road. So what they do is they move the snow away from the road, they store it on the shoulder, and whenever the vehicle can come, it will collect the snow from there. Okay. Yeah, it provides lateral clearance from the roadside objects. Okay, so any roadside object, for example, a sign, a guardrail, or anything is not directly on the edge of the road. It is some distance away from the road. So some people, they lose control or they are distracted. They are looking at the phone and they go slightly towards the edge of the lane. Still, they are safe. They will not just go and hit the object. Okay. Shoulder have more cross slope than the lane. So drainage on the shoulder is usually faster. So it provides you a space where water goes away from the pavement faster. And even if water accumulates, it will not come on the road, it will come on the shoulder first. Okay. And structural support. So because of the slope, it also helps to keep the pavement stabilized. Like I showed you for the side slope, right? Same thing. Okay. So I'll stop here. We have still some cross-section elements to go. We'll discuss them on Thursday, inshallah.
Section 2.
Okay, thank you. You can leave.
You're not in the class?
Huh?
Chennai.
No.